So now we really want to begin our discussion on sets. So I want to start by giving you a definition for a set. All right, so we're going to say, and I'm just going to jot it up here on our screen, we're going to say that a set is a collection of objects. Now, for most of the things that we'll be looking at in our class, these objects will be numbers. So when we're talking about a set, we're usually going to be talking about a set of numbers. We don't have to, but that's our most common example. All right, so we want to keep in mind that the set is the collection. Now, the other term that I want to define right here before we get started is that of an element. So an element is a member of that set. All right, so as an example, let's say that my set contains the numbers, the natural numbers less than 10. So that's going to be my counting numbers less than 10. Okay, so now I have my collection of my objects. Now, an element is going to be any member of that set. So, as an example, one element in the set would be, say, 7. 7 is a member of the set. 5 would be another one. 6 would be another one. All right, so you want to remember set is your collection, and element is one particular thing in that collection. All right, so the first thing that we're going to talk about is how we define a set. And we can use two different methods to define a set. We can use what's called the roster method, which makes a list of all of the numbers in the set. Or we can use the descriptive method, which uses a sentence to describe the set. So what we want to do in this first presentation is to get to the point where we are comfortable moving in between the roster method and the descriptive method for the sets. All right, so let's begin with an example where we want to write our set using the roster method. So remember that a roster is the list of all the elements in the set. So our first problem says A represents the set of natural numbers less than 10. So to write this in roster method, I just want to list those natural numbers less than 9 out. Less than 9. So I'm just going to make a list. Remember, your natural numbers are your counting numbers. And we want to go less than 9. So we'll go 1, 2, 3, 4, 5, 6, 7, and 8. Okay, again, roster method is just listing out your elements. Our second example says we want B to represent this set of natural numbers that are multiples of 9 and less than 100. So think about your multiples of 9. We would have 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. Then we would have 54, 63, 72, 81, and 99. And then at that point, let's see, we skipped 90. So let's go back and put that one in. So we'd have 90 and 99. And so then at that point, we would have all the multiples of 9 that are less than 100. All right, C says to represent the set of all integers. So remember, integers are negatives, positives, and 0. Greater than -3 and less than 4. Okay, so let's think about numbers that are greater than -3. That would start with -2, -1, 0, 1, 2, and 3. And we want to stop when we get to 4 because we want to keep our numbers less than +4. Okay. All right, we're going to look at a couple of more. All right, some that maybe don't involve numbers. We said that most of our sets will have numbers, but not always. So I wanted to show you a few examples where we don't have the numbers. Okay, so again, we're doing roster method. Set D is going to represent the letters in the name Samuel. So again, we're just going to list them out. So we have S, we have A, we have M, we have U, we have E, and we have L. For our next one, we want E to represent the letters in the word Georgia. So we have G, we have E, O, R. Now, one thing to remember in terms of sets is that we never duplicate the elements. So I already have G listed, so I'm not going to list it again. The next unique element would be I, and then we would have A. Our final example says, let F represent the colors of the U.S. national flag. So what colors are on the flag? We know that there is red, white, and blue. And so again, we are simply listing out the elements in this set. Okay, so now we want to go in the opposite direction. So I'm going to give you some examples where we have the roster method and we want to use the descriptive method to describe it. So remember, descriptive method means that we're writing a sentence. Okay, and so for the first set, we're going to start this thing out and we're going to say, let A represent the set. Okay, and then you need to describe those numbers. So what kind of numbers are those? Well, we recognize that those are odd numbers, and they're also counting numbers or natural numbers, right? And so we're going to say that A represents the set of odd natural numbers and we've got to cut it off at some point, so we're going to say let's say less than 10. And then that will mean that we are definitely stopping at 9. So let A represent the set of odd natural numbers less than 10. All right, our second set. If you notice the letters in the set, you can see that it appears to almost spell Halloween. All right, so I'm going to say that we want let B represent the letters in the word Halloween. What about part C? So we're going to let C represent, again, we have letters. Can you tell what word that is? Remember that you're not going to have any letters that are duplicated in your set. So I think that those 4 letters are going to be the 4 letters in the word Mississippi. Okay, so we've seen that. Let's look at a couple of more examples. All right, set D is the numbers -4, -3, -2, and -1. So let's think about how we can describe those 4 values Again, we're going to start off the same way. Let D represent the set. So what kind of numbers are those? Those would be integer values if they have negatives. All right, so we're going to say let D represent the set of integers. And then we have to figure out how to restrict it to just those 4 values. So I think I'm going to say integers greater than -5 and less than 0. And that will force me to only use the numbers -4, -3, -2, and -1. All right, what about for set E? So set E looks like we have multiples of 5. So I'm going to say let E represent the set of what kind of numbers? So we could use the natural numbers on this. And we want to say that let E represent the set of natural numbers that are multiples of 5. And notice in this set we have at the end, we have this ... which means that it continues on forever. So we'll just simply say the multiples of 5, and we don't have to say less than anything particular since we want that set to continue on to positive infinity. All right, our final example says that set F is the values -3, -2, -1, 0, 1, 2, 3. So hopefully you are recognizing those as integers. So I'm going to say let F represent the set of integers. And then think about how you want to restrict it so that you only get those values. So I think we want to go greater than -4 and probably less than +4. And that will keep me in between those 2 values.